Ladies and gentlemen, hello and welcome back once again to the briefing room. Yes, indeed, my name is Eric Cavanaugh. I will be your moderator for today's event. And folks, this is a wonderful topic we're going to talk about today. I love this topic. The title is Enabling Flexible Governance for All Data Sources. But there are even more exciting things we're going to talk about today. We're going to talk about going rogue. We're going to talk about shadow systems. We're going to talk about finding a way to get the analysts on your business team the data that they need so they get the insights that can help your business, and doing so with guardrails. I love this concept of guardrails. Well, there's a slide about yours truly and enough about me. So the mission, as many of you now know in the briefing room, is to reveal the essential characteristics of enterprise software. In order to do that, we pit analysts with vendors who are doing interesting things in a live analyst briefing. So the analyst and vendor do not coordinate before the show, and the reason is because we want to preserve that kind of natural conversation that occurs when an analyst will take a briefing from some vendor in a space that they cover. So that is the format. It was inspired when I watched my partner, Bloor, who's going to be our analyst today, take a briefing from a vendor at a show several years ago, and I was amazed at how quickly he was able to bring out a very productive conversation about the kernel of a technology, how it worked, why it was designed a certain way, and in which business scenarios it made sense. So I was very impressed by that and thought, we got to bottle that, and that's what we did with the briefing room. So we cover a different topic every month. February is analytics. You can see the upcoming topics: operational intelligence, that's a rising theme or a rising discipline. And then April is intelligence, so BI, for example, reporting, that kind of fun stuff. May is integration, and the rest of the calendar also has topics per month. The reason we do that is to help you as the end user get a good apples-to-apples comparison within one calendar month of a particular domain. So if you're getting ready to pull the trigger on a piece of enterprise software, ideally you'll be able to get a lot of good insight and detail about these different solutions within one calendar month. So let's talk just very quickly about the topic today. You know, if people are using shadow systems, if they go rogue, that's usually because they grew frustrated with trying to do things the right way. And what happens when the laws or the rules are too strict is people just go around them. That's all there is to it. Business analysts need to get things done. If they can't go through the data governance process, or the data governed process, I should say, they're going to find some way to get data that they can use to make decisions. Well, if they completely circumvent data governance processes, of course, there are risks to that. There are risks that they're using faulty data or data that they shouldn't be seeing. There are all kinds of things that could happen. You could make very bad decisions, frankly, business catastrophic decisions, if you're using wrong data, unclean data, if you will, to make very serious decisions. So what do? You want to be able to govern your data. You want to be able to govern your processes, but you don't want to constrict your business users, your analysts, to the point where they just get frustrated and go rogue. So we're going to talk today about how you can essentially achieve both accuracy and agility at the same time. It's a very sophisticated system. I can tell you that. It's an architectural system when you get right down to it, but I think you're going to see that it is absolutely possible to do that. And I would advise anyone who has these issues that they definitely should be thinking about this pretty seriously. So there's a slide about Dr. Bloor. Of course, he's the chief analyst here at the Bloor Group. And Birst. So Birst has a SaaS-based, software as a service, multi-tenant BI platform. It can also be deployed on-premise. I've been following these guys at Birst for quite a few years now, and have been very impressed with how well they have built the underlying architecture. They're very good at showing business users which data sets they can use, at creating a fairly intuitive interface, allowing business users to find the data sets that they need and then put them to use to get some analysis. As many of you know, a lot of these systems can be very, very complex, and you need a big manual to read it all day to understand how to do this or how to do that, and that's not good. You don't want that, because again, what does it lead to? It leads to frustration. It leads to people going around the processes and doing things on their own. So Brad Peters, he's the CEO and co-founder of Birst. He spent the last 10 years building analytics products and solutions. You can see he's been around. He used to work at Siebel Analytics. Well, of course, that's a product that was bought by Oracle. It's with that OBIEE product that I'm sure you guys have heard about. He's very experienced and understands the business side as well as the technical side. So with that, I'm going to hand the keys over to Brad Peters, who's calling in from the road today. And with that, Brad, the floor is yours.
Thanks, Eric. Appreciate it. So I appreciate the opportunity today. I wanted to step back and give folks a bit of a background to some problems that I think we've been seeing, at least in the world of analytics. A lot of symptoms of this underlying problem over the last 10+ years. And it seems that there are a whole lot of approaches that people have taken to bringing data together across an organization, but the byproducts of that have been a variety of different technical side routes that people have taken to bring data together, and you know, we've been dealing with these issues for a long time, and wanted to pull it together in a new way. So you know, Birst as a company, we provide business analytics solutions. We ingest or connect to data in various enterprise sources, and then provide business users or analysts a way to get at that data. And you know, at a high level, that's the BI mission. That, you know, you can go turn back the clock 15 years, and you know, when the term BI was originally termed, even before that, there was a concept for how this whole process was supposed to work. And it was really go take data from whatever applications were generating or managing or using that data, ERP, CRM, homegrown systems, whatever it might be, all these systems which were designed to automate some sort of operational function or some sort of capability, and were generating data in the meantime that people wanted to be able to then analyze and leverage. Let's suck data out of those systems, and let's create this thing called a data warehouse. And the vision of the data warehouse was it's going to be this place where we put it all in one spot, and if we put it all in one place, it'll be great, because then we can put a BI tool on top of that, and we can get answers and insights out to our business users in the organization. And data warehousing became this holy grail. If I put all of my data physically in one spot, life will be wonderful. And it's a great vision of where the world would like to head, except that very quickly after that vision was conceived of, it started to break down. And the challenge with a centralized repository, a single centralized repository, isn't so much that there's a physical database handling data from multiple different sources. It's the central management of that data which has been a big stumbling block in most organizations. It's the business management side of data, not the technical side of data, that was an issue. And so what you found was organizations spawned large projects to put very specific, high-value sanctioned data sets into these data warehouses, but other data sets which didn't quite meet that threshold or bar, or more transient, didn't meet the regulatory reporting requirements or whatever it might be, never made it into this central repository. And also, you know, when the organization who was sanctioned to manage this thing, IT, when they did take responsibility for data sets, owned those data sets completely, and as a result of that, were responsible for the integrity and management and delivery of those data sets out to end business users. And that can be, you know, those responsibilities can mount as the organization wants to consume and leverage more and more data sets. And there's really organizationally limits to how much any one organization can really support. And so there was a lot of scalability limits that hit quite quickly around that process. And so we very quickly saw a 2.0, if you will, version of that model emerge, where standardized processes pulled data out of enterprise applications or homegrown applications, whatever, and put them into an enterprise data warehouse. And to some extent, sanctioned ETL and governance processes were applied to those data sets, but they weren't, and maybe some BI projects were leveraged against that, but the goal wasn't so much to actually do analysis in place. The goal was just to collect the data and then allow some sort of downstream processing or consumption of that data to happen. And what we ended up seeing is this notion of distributed data marts, the hub and spoke model up here, where individual departments who had their own data sets, which weren't part of that managed governed set of master data, needing to merge that with the officially sanctioned data sets and basically arranging for one-off data feeds, in which case the data warehouse largely became a staging area for various pockets of data. And for certain sanctioned batch ETL processes and maybe some enterprise-level reporting, but a lot of the analysis ended up being distributed to individual data marts throughout the organization. And as a result of that, we saw the rise of cubes and ultimately in-memory systems and a whole bunch of things which were really designed to make that one-off subset of data more easy to manage. But still, you're talking about setting up lots and lots of redundant infrastructures. You're talking about taking data that was at one point secure in the data warehouse and distributing it out in ways that are vastly less secure than if it was to stay in the data warehouse. You're talking about losing any of the business rules and business modeling that was associated with that data when it was originally put in the data warehouse in the first place. So even though the data may be sent out to various folks, how they use it, is pretty much Wild West. And you're also talking redundant infrastructure throughout the organization. You're talking skill sets that need to be maintained, and you're talking about duplication and distribution and infrastructure that can be expensive and brittle. And it certainly functions. If it didn't function at all, we would have very little ability to consume data in organizations today. So it certainly does work. But it's a far cry from the vision that was originally out there of let's create this virtual pool of data and allow folks to tap into it as they need to and maintain a degree of governance, consistency, and security standards, all those kinds of things that you need to, but also make any available data available to those who need it when they need it. And in fact, what really happens even more often likely is that that BI system against that data warehouse turns into just a data extract system where we really don't care what reports or what analysis or what great dashboards were built on that thing. We're simply going to press, print to PDF or dump to Excel, bring it down to Excel, and do all the really useful work on the desktop. And then, of course, you lose the single version of truth. You lose the ability to figure out what was right when. You lose the time series integrity of data, and it becomes even less managed than the situation of distributed data marts. It's sort of spread marts or micro marts, the ultimate going rogue in the organization. And when that happens, data takes on a life of its own, and a lot of the benefit of bringing it together in an assimilated way is lost. And so, what really needed to happen, or what needs to happen in these organizations is we actually have multiple different classes of data within the enterprise. There's data sets that IT or some central organization must manage and apply a high degree of governance and management to ensure it meets certain consistencies and standards. That is absolutely the case. There are other data sets that don't meet that threshold and shouldn't, because agility is actually more important than that degree of governance and process around it. And in fact, if you were to weight it down with all that process, you would limit the business utility of that. And there are other organizations who understand the business context of those other data sets that are probably more qualified to take ownership of the management of that data, but they certainly aren't in a position to manage some of that central data in the organization. So you really have two classes of data in an organization: the stuff that needs to be managed and run agilely locally, and then the stuff that needs to be governed and managed centrally. And really, if you in the ideal world, you need an infrastructure where these different data sets can live side by side and ideally connect to each other in a way that they're both usable together, as opposed to one lives in one place, we take an extract of it and move it to a different place, and then we put it in a completely different infrastructure. If you can manage both of those data sets in one place, you can do some really interesting things with that. And in the world of software as a service, we call that multitenancy, where multiple different owners can coexist and manage their own piece of the pie side by side without interfering with each other. And as part of that, we introduced a concept last year called managed data mashups. And the whole idea of a managed data mashup is to mash the managed data in an organization in a managed way together with data that's distributed throughout the organization as individual analysts or business analysts or departments might generate in their parts of the organization, and let both of those data sets live side by side in the same environment where the overall security management infrastructure meets the enterprise standards, but there's distributed ability to manage pieces of that data or sandboxes by business users, folks who aren't DBAs by trade, There are certainly database infrastructures that allow distributed DBAs to load data into databases and do stuff like that. But your average department isn't going to be able to do those types of things. Certainly without technology infrastructure. Ideally, you have individuals who are more business analysts be able to manage their own sandboxes alongside with the more technically managed stuff that's managed centrally. And if you think about what software as a service is about, we really wouldn't exist as a company if we didn't allow people from a remote location to be able to create their own sandboxes in our cloud of data sets and then be able to do analysis off of that. So one of the things that we had to do as an organization and as software as a service is we had to manage the data into the system and provide a business analyst-friendly way to manage data into the system, as well as allow folks to query and analyze and consume that data out. In the world of BI and analytics, historically, those two things were completely separate systems, completely separate companies, completely separate architectures. BI systems didn't really care how data got into a system. They just assumed it was there and naturally prepped and managed and well-tended. And data infrastructure systems that would, ETL systems, assumed that everybody who operated them were extremely highly trained ETL professionals who understood databases and data movement and all that sort of stuff. And it wasn't something you put in the hands of a business user and ultimately had no direct knowledge of how that data would ultimately be consumed. We had to, in the world of software as a service, unite those things so that entire end-to-end data flows could be managed by a single business analyst, and where the insight happened a couple years ago was, hey, if we can manage these things separately, what if we allowed people to connect them? What if we allowed people to take different data sets managed independently and link them together so they could, without moving data, get the benefits of each of these different data sets without any physical duplication of data, without any movement whatsoever. Let's just let people logically link those data sets together and query them together in tandem. And if we could do that, we could actually blend both of these worlds. So instead of doing the hub and spoke, take data feeds out and distribute it, let's move the data back into the warehouse. Let's put a system on top of that warehouse. Let's put all the data together in the same spot so that it physically resides in the same location and meets all of the highest level enterprise governance and security infrastructure that we want, but let business users retain control of pieces of that infrastructure themselves so that they can upload spreadsheets and data sets and do analysis and relate that to the interesting managed stuff that's central in the organization. And really, it comes as a byproduct of developing an architecture that has to handle both that data in and analysis out part of the problem set, which was unique to our to the cloud, where a lot of data like that, if we couldn't get it in, we certainly couldn't get it back out. But we also wanted to be able to support existing infrastructures that were there in the first place, that was already managed by IT or whatever organization was there, and let people flexibly manage those data sets together. So what I'm going to do is quickly go through some high-level concepts. One of the challenges with managed data mashups is that it is a fairly abstract concept, but fundamentally it fits well with a concept that is pretty core to Birst, and that is a space. In the world of Birst, we have a space is basically a virtual analytics instance. It includes data, metadata, reports, dashboards, all the things that go with it. And when you build a space, you either import data into Birst and we manage the data, or you connect Birst to your existing enterprise data warehouse without moving and just model the data in Birst. But regardless, there's a modeling framework, and once the data is modeled, people can query, report, and analyze on that data set. And what I'm showing right here is just an example of, let's just say, a sales analytics data mart. I picked one that was of fairly modest degrees of complexity. There's ones that are obviously much more complex than this, but where you might have 20 or 30 different tables modeled by technical folks producing a data mart or data warehouse, or maybe sitting on top of an enterprise data warehouse that's there. But obviously this degree of interconnection of data sets, and it doesn't really matter what all these boxes are, they're just different pieces of data, and there's data flows and data movements. But this modeling is something that a data modeler or a technical person would either map onto an existing data set or create in Birst, but would be something that would be a more specialized skill set. Once that's done, obviously you've got some nice, rich master data, customer data, opportunity data, sales data, that would likely, would want to be consumed elsewhere in the organization. And the classic thing that we saw in the sales context, is just to make this more tangible, was marketing folks running one-off campaigns and wanting to know, did anybody buy anything when I ran that campaign? Well, they had a nice list of names of folks that they ran that campaign to, but the actual follow-on sales data of who did what and who bought what was maintained centrally in a data mart such as this. And so what we allow folks to do is to create pieces of that master data structure, what we call a package. Let me just take the customer table. Let me just take the order table, whatever it might be. Just that simplified data set that's already cleansed and managed and pure, also containing any security filters and infrastructure that's there. Let me package that up as a package, and then make that available to an end user business analyst to consume directly without having to know all the rest of the stuff that goes on in the data factory behind the scenes. So if I'm a business user and I upload a campaign table, just illustrated here, where I might have a campaign with an email and company, industry, whatever it is, the things that I as a marketing person would know, I can basically import that contact information, the sales information, into my space. I see 3 boxes now in my little data modeling view, and this is vastly simpler than what I would have seen in if I was managing that centralized data mart that I was talking about before. This blue box right here is my little campaign table that I uploaded. I got this red and green thing here, which are 2 tables that were essentially imported into my space, although no physical movement of data actually happened. They just present me a virtual image of the already cleansed data. I link my campaign table to that contact table, and now I can start doing reporting of contacts versus campaigns and even sales amounts without actually even having to know how that sales data was even modeled, because that was taken care of for me. All I needed to do was link my campaign table to the table that I imported into my own little sandbox virtually, and now I can do cross-area reporting. So as a business user, didn't have to understand all of that complexity under the covers, and that allowed me to tend my own data set of my one table, but still take advantage of this nicely governed, centralized sales data that was managed for me by a different group in the organization. And they didn't have to make a data feed available. They didn't have to move any data. All they had to do was publish a package that I was able to just connect it to. So that's really the usage model that we're talking about here, and that's the capability that we're talking about in terms of managed data mashups. So with that, Eric, I've just got a slide here about Birst for those folks who might be interested, but I'm assuming that it's Robin's chance to chime in here.
Yes, indeed. So let me go ahead and push Robin's first slide, and Robin, I'm going to hand the keys to the Webex over to you right now. And folks, we have some awesome questions already. Thank you so much for sending those in. We'll get to those in the Q&A after Robin and Brad finish their chat. But with that, Robin, the floor is yours.
Okay, Eric, thanks for that. Okay, what I kind of thought I'd talk about today is just the plumbing problem. And I think to a certain extent Brad's gone into this in reasonable detail, but I'm going to go into it from my particular perspective. The thing that I think that's kind of important or becoming more and more clear is that the activity around BI is actually expanding, and at the more sophisticated end, we now have the term data scientist, and we've got a whole heap of data analytical activity that didn't used to happen so much. And that just exacerbates the problem that Brad mentioned and that I'll now talk about in my own sweet way. I mean, first of all, we can look at this in terms of data flows and data pools. In terms of data pools out there are transactional databases. There's what we call data warehouse. We had the invention of something called an operational data store that was really put in place because data warehouses weren't fast enough in terms of the up-to-dateness of the data. And therefore, some companies created operational data stores which tended to grab information from transactional databases without cleaning it, governing it, or doing any of those things that you're supposed to do, or that maybe you should do, making it immediately available to run dashboards or for various reporting purposes, just so that it was timely. Then we've had the intervention of Hadoop, and Hadoop is, in various ways, there are so many different ways that people use Hadoop that it's a little bit difficult to generalize, but it's become a repository for data and has been referred to as a data reservoir. And so that suddenly becomes a data pool that didn't exist before. As Brad's pointed out, we had data marts and we had desktop data. So these are all pools, and that's leaving aside the various things that we call staging areas, which are where we dropped data because it couldn't be injected directly into where it was going. So that, you know, it's a really complicated world out there in terms of data pools. And it's very, very difficult. I would have thought for most large organizations, I think it's extremely difficult to actually get any order in this because, you know, if you run a project to actually set some order around where the data stores are, then someone's going to come and ask for something in the next year or so that's going to mess it all up in one way or another. Another initiative will start and it'll disturb that. We also have data flows, and we've had data integration flows forever, but we've now got external streams coming in. We now have the unstructured data starting to be a significant factor internally. That's emails and text. We've got people are now taking information from log files, sometimes directly, sometimes dropping in the data warehouse. And we've got what's called machine-generated data, which is supposed to be the next generation of things for us to worry about, and we're inundated with people data from social media, or those companies that care about it, and we also have archiving. And the reason I put archiving in there is that I remember, like 10 years ago probably, people got very excited about data life cycles. And I can understand why they got very excited. You know, once a piece of data is created, it's got a certain value at a certain point in time. Probably isn't worth your while keeping it online, but you don't want to destroy it absolutely, so you archive it. Well, it's one of these things that with the advent of what people call big data, we started to forget about the nicety of data lifecycle and the archiving of that. And in terms of data lifecycle, I should go to the next slide. There's a whole series of processes that I think of as data flow processes. You know, at the end game at the bottom here, we have some BI and we have some analytics. All of that activity. But we have various processes that relate to security, the absolute governance of data, the cleansing of data. We have ETL. I mean, we're showing it at the top, but pretty much at any point you can be doing ETL from one staging area to another or from one data store to another. And we also now have Hadoop, which is used quite often as just the source data store that you throw queries at to drag things either into a data warehouse or into something else to act on directly. So what we have here, and if you talk about, I mean, for instance, we could be, but we aren't, of course, today, but we could be going on about MDM, and if you talk to MDM people, there are a whole bunch of rules that we'd like to apply to data before they're used. And it's really kind of inconvenient in a lot of ways because there's never necessarily a right time to do it. Like, you know, cleansing data is a really good idea to cleanse data at source, but sometimes you actually can't cleanse data at source because the person that discovers that the data's bad happens to be the BI guy. You know, so there are various points at which cleansing can happen. There are various points at which governance should, in one way or another, be applied. And there are various points where security should come and act. And it isn't necessarily clear with any piece of data when all of those things are going to happen. In other words, what I'm saying is the plumbing looks awful. In fact, the plumbing looks a bit like, because I think this is awful plumbing, a bit like the picture I've got here. Or it can do. So that's what, that's a kind of background, but I'm painting the worst possible picture. There's a data flow analytics issue, and the diagram that I've drawn here is really fairly simple. I've divided the whole of BI roughly into 3 levels of complexity. One is that you're just getting results extracted from various sources in one way or another and then being fed directly to users. It's true, and I think Brad's completely right that you have rogue users. I think you've had rogue users actually really in the days before BI. I think as soon as users got spreadsheets, they started to be rogue users. I remember coming across a company in about 1992 where a whole bunch of users had got together and written their own system in a spreadsheet software, gathering their own data, validating their own data completely outside the bounds of IT. So that kind of behavior has been going on for a long time. And it's something that I'm intending to chat to Brad about in actual fact, because I think it's kind of interesting. A lot of those people weren't trying to undermine, they weren't trying to create a revolution. They're trying to do the things that their jobs involve them having to do. So to a certain extent, the problem wasn't so much rogue behavior as a breakdown in the flow of data to these people. The second thing we've got here is the source extract and the temporary data store that you interact with. This is what Birst is clearly catering for, and it's a really good idea that this becomes self-service. Where it's not self-service, you get the friction that occurs between IT, where users ring up and ask for something, and IT says, well, you can have it in a month, and they say, well, I want it today, and that's a constant source of problem. And then we got the final situation, which is as bad as it can get, and this is really more data scientist activity. But basically, the guy who's a data scientist isn't just doing deep analysis into stuff. He's also at various points in time reviewing the data that he's actually got his hands on, and possibly deciding that he needs to actually supplement that data with other stuff. Or maybe he had drawn off some subset of data in order to do some kind of sampling analysis, and now he wants to do the full analysis. So this guy, above and beyond anybody else, absolutely does need to have the maximum amount of self-service possible to get at data. And therefore, this guy, I mean, in one way or another, this guy has got to also be an expert, not just in the statistical analysis of data to reach sensible conclusions, but also in order to extract data and understand the timings involved in pulling data out of things. He can complete his job if he can make extracts happen, let's say, in minutes rather than hours, or in hours rather than days. It's a problem at that particular layer. So that, in a very simplistic way, is the way that I kind of view this. But then, just looking at the comments up top, well, all the ETL, governance, cleansing, security, etc., all those processes need to be factored into this and made to apply when they need to be applied. And that's why this is a tough problem. That's why, in one way or another, the whole of the data integration market actually turns out to be a huge market. And then, at the same time, data has to move as fast as possible, or at least has to move as fast as the user would like it to move. And it turns out that's not so easy to achieve. In actual fact, it's very hard to achieve. And I mean, I could go into technical depth about a fair amount of what's happened technically in the past 5-10 years to make this just turn up to be a bigger and bigger problem. But instead of doing that, I shall go on and start asking Brad some questions. The first question I'd really like to ask Brad is about, I mean, I know what you're doing here with, or at least I think I know what you're doing here with this master data mashups. But there is this issue of repetitive self-service where a user, having grabbed something, actually turns out that they'd like to grab more of it, or they'd like to grab that and something else. And so what I'm trying to kind of get to with this first question is, where's Birst's capability go with this? What's, user self-service, in my opinion, is an excellent idea as long as the users don't start destroying the performance capabilities that lie underneath. So what's your limitation in terms of what you can provide here?
That's a broad question, obviously. But what what an infrastructure like Managed Data Mashups helps one do is remove some of the physical repetitive nature of that self-service. So someone takes a data feed from a central repository, they do it once. Then they want to do that analysis again. They've created an awesome spreadsheet, or they've used a visualization tool to create a nice chart. Next week, a new data set comes in, they got to pull it out and go through that whole process all over again. Well, a tool like Birst is really designed to model the source data in place so that it's always fresh. You go back and once you query it again, it's giving you the fresh and updated. You don't have to re-pull the data once it's there. So you import that logical package once, and you don't have to repeatedly go grab it. It's always there. And then if you want to update and add, some of your own data on a repeated basis, then that's absolutely, what you can do. So we see actually a fair bit of that in our customer base. Part of our emphasis, which differs from maybe some of the visualization tools out there, which are really designed for kind of one-off point-in-time analyses, much of the infrastructure of Birst is designed to create repeatable processes where you model it once and then the act happens over and over and over again and saves you time down the road. It's all about building analytical applications, if you will, creating an infrastructure for building a repetitive analytical app where the data is constantly being updated and refreshed. That's core to what we do.
Yeah, I mean, I would kind of agree with well, I don't even think it's up for debate. I would agree with what's happened. I mean, because the other thing is that one of the underlying things, one of the reasons that we can talk about the data warehouse architecture as it was and why it got into trouble as it was later, is we were always thinking in terms of snapshots, in the sense that we were always thinking, okay, the data warehouse will reflect the data at the end of the week or the end of the day or something. And we gradually have moved into an environment where I started thinking, I think at the beginning, sometime during the middle of last year maybe, that actually this is all data flow now, and there aren't any necessary snapshots, and therefore if you can make data flow, then you should be getting it to flow to its next points of usage.
Well, that's the whole nature of an analytical app, which is, the reason you come back tomorrow is that the good work you did to create those calculations are now updated with the latest stuff so that you can see that over and over again, and you're not hand producing that spreadsheet or that visualization over and over and over again. There's a little bit more work up front, but it's amortized over repeated use. And the data sets that we see behind the scenes, these applications, they are constantly generating data. And people are moving to this transitory environment where data is effectively real-time enough. It may not be, down to the second, but it's certainly, pretty frequently updated.
Yeah, I tend to use the word near real-time because, one person's real-time is different from another person's real-time. In time is normally real-time. You know what I mean? Which is a kind of an interesting thing. I'm kind of interested because, I mean, you guys have been really successful for quite a while, and I'm kind of interested, is the data that you're handling now starting to change shape? Because an awful lot of our thinking around data as well is corporate data, but now when we're not, I mean, first of all, the corporate data is no longer well defined because some people are actually pulling stuff out of logs files that they didn't even think of as sources of data before from within the corporation. And then a lot of stuff's coming from outside, not just up and down supply chains, it's also the social media stuff and so on and so forth. Are you seeing a lot of that happening amongst your customer base?
Sure. Analytics is no longer the realm of the people in the bowels of the organization. It's now something that everybody in management cares about, and it's visibly strategic. Certainly when consumer applications out there are doing more than with data than what a lot of enterprise applications do. You see that. And so what we've seen is, there was this hierarchy of data in organizations, obviously financials and core orders and stuff like that. Well, people put a lot of work around that. But what we've seen is an expansion out from that in multiple rings. sort of tier 2 applications or other applications which may not have been quite so, enterprise core or standardized. Those are being pulled in as data points. So even before you get to the unstructured or the other types of data that are out there or unmodeled data, there's a whole general tier of other applications that are out there. And I think the other broad category that we're seeing that people want to include is user activity level data. We see a lot of that, which before it was more, if as a result of all this activity they bought something, let's record the fact that they bought something, but we didn't store all the things that they did leading up to that point. And the whole web analytics field taught people, it was the real precursor to big data, was actually let's capture all that individual fine-grained activity data so that we can correlate that with the outcomes. And now we're starting to see, at least at Birst, that the web isn't the only place where we can capture and grab user activity information, and that can become very, very valuable in a whole lot of different ways. And that's stuff that we would have let hit the cutting room floor before, but now we're collecting it, we're aggregating it up and allowing folks to correlate that with that more traditional stuff of the high value business outcome that we saw. So we're seeing definitely the shape change. And the scale is significantly larger than it was even a few years ago.
Yeah, I was going to go on and talk about scale, because that's the other thing that I noticed. I mean, people talk about big data, but I don't like the term, and I've never been particularly happy with it. But the more that I think about it, the less I like it. It's not that the data's big; it's that in one way or another, the whole performance demand is higher.
Mm-hmm.
And that can manifest itself in many ways, but at the end of the day, it normally manifests itself in a user, possibly a very important user, complaining that the data isn't arriving on time. So, the obvious performance question, you didn't, and I know your presentation wasn't pointed at that, but you didn't talk about the performance aspects of Birst. So I thought I'd give you the opportunity to do that. If we just think, well, a long time ago, a 10% growth rate in data was an unusual thing. Now 100% a year is not unusual at all, and it can be much worse than that. So how does Birst scale?
Yeah, I think the big revolution from our perspective over the last 3 or 4 years has been the whole thinking about how we parallelize access to data. So before, it was stick everything in one database, on one machine with one, set of processors and one set of disks, and maybe we bought really expensive disks, but we sort of hit limits as far as that goes. And what we have with Birst now is a scalable set of tiers of performance that we can apply to data depending upon the size. So obviously you can analytical databases and things like that give you speed, but when you can start parallelizing that across many nodes in a very scalable, sort of share nothing way, and you start being able to flexibly allow people to partition data sets into small pieces, that is really, one of the great things about Hadoop was coming up with a very scalable way to parallelize processing over large numbers of machines. And the same thing is true for structured data, which is, we can ingest unstructured data, but our core has generally been structured data. The same thing is true in the structured data world as well. When you can parallelize things at scale, then you can get into, then all of a sudden you're not talking tens or hundreds of millions of records, you're talking billions and tens of billions of records, or even more than that. And that's how we do it. We have a number of ways that we can parallelize the infrastructure across many different equally powered commodity boxes to be able to give us that scale.
So on what triggers that? I mean, because I'm sitting here and I'm thinking, well, okay, you've got a SaaS operation, you've got a multitude of users out there, and at a certain point in time, you're going to make a decision to force scale out in one way or another. So what triggers that decision? Well,
there's capacity planning. I mean, even with Amazon, you have to provision your boxes before you can turn them on. They do have some auto scale features, in that world. In our world, we need a little bit more lead time on it than that. But as part of the capacity planning, you should have a good sense, some lead time on how much you're going to be aggregating and what the loads are going to be. Or we can help with that, or there's partners that we have that can figure that out. And so we generally try to size people into something that we know is going to meet their needs, for some foreseeable horizon. And then if they hit certain thresholds of utilization, we can add more capacity over time.
Yeah, and I mean, but you guys are a multi-tenant operation, is that right?
Yes, we are. But multi-tenancy means many things. And when you really get to the world of databases, there's nuances to that word. The key element for us is the application tier is 100% multi-tenant. But when you're talking I/O, which is really the core of analytics, when you have to sweep very large data sets very, very quickly, getting dedicated IOPS for individual, for individual instances, we can provision dedicated, I/O capacity for people as they need it. So the base system is fundamentally multi-tenant, but the parts that are reading from disks, we do some things to dedicate stuff when people get to certain scale.
Okay. Okay. I mean, the next question that's on the slide here was just like, as I was looking through your slides when I put my presentation together, I saw this word, automated multidimensional database, and just thought I'd ask you, what is that?
Well, if you think about, so part of what our challenge was early on in the company was we had to build analytical apps for our customers. They would drop off data sets in whatever format they came and expect to be able to analyze, slice and dice, drill, navigate, do all the cool things that you want to be able to do on those data sets. And the conventional thing that you do to data to make it sliceable and diceable is you make it multidimensional. And the whole discipline of building dimensional data warehousing was really centered around that concept of how do we create dimensional models on top of data such that they can be flexibly browsed. And what Birst has in its data management layer is part of our core technology is once you've created a logical multidimensional model of your data, we will physically persist that in a database infrastructure. So we will create effectively, a virtual data warehouse for you without you having to do the ETL infrastructure, the physical table creation, database management, all that sort of stuff. And what you end up is, mapping these dimensional concepts onto regular tables, and we construct a data warehouse infrastructure, a multidimensional database, if you will, from that data that allows people to very flexibly slice and dice it. So think of it as a data warehouse in a box on some level.
Right, and I mean, are you doing that per user, or are you doing that in a kind of collective way?
Well, not per user, per modeled data set. Each data set is unique in its characteristics. Right. It's the same system, a lot of shared resources, but we create something that is unique to the data model that's, when you model something in Birst, we then make that physical for you.
Without anybody asking and anybody having to think about it.
They have to understand the logical structure of data. There's no getting around that. But a lot of the physical mechanics of making that real with, indexes and foreign keys and surrogate keys and type 2 slowly changing dimensions and all the things that I just want to know that this thing is going to change. All that mapping of technology under the covers, that's stuff we want to automate for people.
Yeah, and I mean, it's obviously a very intelligent thing to do. Okay, so this is the question which is, part of the set of ideas that I walked through. It's like one of the problems that, the whole of most of what you do with data could be called data governance. Some people take data cleansing as separate and data security as separate, but it's a set of rules that should be applied to data. So I was just really interested in your attitude to all of that data governance stuff and where it fits within your technology.
Well, so before we had some of these capabilities, there was this perceived trade-off. I'm going to have data on which I apply data governance, or I'll use an agile system like Birst. It was kind of an either-or. And we didn't want that to be the trade-off. So what we wanted to allow was, we're not a data governance tool, but we want to be able to sit on top of data governance or systems and database infrastructures for which data governance has been applied, respect that data governance and those data policies, help to preserve that for end users and help end users leverage that data, but also allow folks to, in a managed environment, mix that data with ungoverned data or less governed data so that they can get more value out of it. So we're not replacing data governance infrastructures, but we're helping to make sure that once you run it through that thing, it doesn't then become the Roach Motel for data where data goes in but never comes out. We want to make sure that that data can live and coexist with other data sets in the organization, and that business users can effectively mine and leverage it, without violating the policies that were there in the first place.
Yeah. Okay. So effectively, you're wrapping what they call in France a cordon sanitaire around the data that you know has been in one way or another properly governed, or that people believe has been properly governed. Correct. I'm afraid I'm going to have to hand you off to our audience because I've run out of time. But I'm sure they have a lot of good questions for you. Eric, would you like to take it back?
Yes, indeed, and we do have lots and lots of great questions. I'm going to push this slide because I just love this slide. Managed data mashups. It's a very sophisticated way of dealing with a very intractable problem. That's, I guess, how I'd put it. So let me just kind of dive in here. Hold on one second. We'll try to go in order. So one of the first questions from the audience, is the data physically stored separately in each sandbox? In other words, not normalized?
Good question. Normalization's sort of an orthogonal issue. Whether it's normalized or not is not as important. Where it's physically stored is. So what we do is we sit the Birst environment on top, often in the form of an appliance, but potentially also in our cloud, on top of an existing database, data warehousing infrastructure. So it is physically sitting next to the governed data that's there. But end users do not, they interact with that data through the Birst user interface. So they don't have the ability to directly manipulate the governed data, but they have the ability to put their data into that same physical environment with some guardrails to make sure that overall system performance and system load and those sorts of things are managed, as well.
Okay, good answer. And what skill sets are required to support the different kinds of users or different sets of users that a company might have?
So the typical use case for this is the data warehouse that exists, the governed data, is already there. So it's whatever processes are already in place. We're not doing anything with Birst other than sitting on top of that and reflecting the data model and creating a metadata model on top of that. So there's some data modeling or metadata modeling skill sets. Anybody with who would have been associated with that initial exercise would be comfortable doing that. And once that data is modeled or mapped into Birst, it can then be made available in terms of packages. For the sandboxes, think of these as a multi-tenant discovery tool. So imagine someone just uploading a series of spreadsheets or whatever it is. It's not you don't need to know about dimensional modeling, or if you understand what a table is, I think you're pretty good. If you can link a column in one table to a column in another table and say these are the same things, that's kind of the extent of the skill set from a modeling perspective. And then obviously Birst is also a front-end BI and analytics infrastructure, so those folks will, people who are data savvy, who understand how to do pivot tables and how to think about how data can be aggregated and sliced and diced, and we provide an analytical framework for them to go do that. So there's really two user classes there. One's more of a business analyst, and one's someone who's modeling on top of the existing data warehouse that's already there.
Gotcha. Okay, good. And another question that's related, where is it? Let's see. So the data is not physically moved with the mashups. I'm guessing Correct. Usually that's the case, right, or always? Correct.
The idea is to do this in place so that you can leverage, the scalability. The old fire in the wire problem is the more you move data not only are there governance issues, but there are performance issues. If we can co-locate the data and let them be separately managed, we can do some cool things with it.
There you go. And how is metadata of these different sandboxes managed? You kind of hinted at that a moment ago, but can you go into it more?
That's what's managed separately. So we have a couple different modes of Birst. We have an advanced business analytics mode where we can do sophisticated mapping and modeling of an existing data warehouse. And so there's an IT person or org would take the existing schemas and map that into the metadata model in Birst and make packages. The sandboxes function in our discovery mode, which puts a much lower burden on, it doesn't require that much as much. The modeling sort of happens under the covers without you really knowing it. When you load a table, it's auto-modeled when it's loaded. So the idea is to not make you have to do a ton of you don't really need to even know the word metadata. You can load the data in, link a couple of columns, and you should be good from an end user perspective.
Okay, good. And there's a specific question about this slide. Someone is asking, is that package you're talking about, that's a custom-built package, or is that proprietary, or what is that?
That package is a package of Birst metadata, effectively. So it's in the Birst tool. So you effectively take modeled constructs that were in your warehouse and assemble views onto tables and join relationships and things like that into these kind of virtual tables that are there. And you can even take calculations and metrics and stuff like that and build them in so that when somebody imports that into their discovery space of Birst, they just appear as if they had modeled them themselves.
Okay, good. Here's another very, very good question from someone who obviously has been in the trenches before. Is there data lineage available of the mashups to verify that user mashups and modeling has been done correctly?
So we do have reporting on metadata, and we do allow you to analyze and search metadata to see where things went. But part of the advantage of the managed data mashups is that the modeling is done centrally. So if you export a series of measurements and dimensions as a package, a couple of those as a package, the way the calculations are defined, the way the joins are defined, all of that metadata is already in that package. So an end user can't mess that up, which is different than a data feed where you're just shipping in the raw data, and the whole way it's joined together and managed is you need the end user to know that. In managed data mashups, you can encapsulate that logic in the package.
Okay. Here's a real good question. One of the attendees writes, data from an ERP can change after it's pulled, such as credits posting late, backdated journals, whatever. Is Birst really pulling data, or is it reading the ERP database for each query a user may have?
So we're querying databases at our core, and generally we don't recommend querying an ERP database directly because of the performance impacts and those sorts of things. What we generally recommend, it can be done, but you want to be careful with that just for creating load on the system. Generally what people do is they take snapshots or pull bits of data, incremental pieces every so often. It could be done every 5-10 minutes, whatever it is, but move that into a different staging environment that can be used for analytical purposes.
Okay, good. And another specific question, when business is creating their own data entities for reporting and decision support, when and how does the data get reconciled to IT repositories?
So that's a good question. So some business unit creates some really cool stuff, and you want to reuse it throughout the rest of the organization. Can you then kind of promote it back to the central governance model and let that get absorbed into the greater whole? The answer is yes. So in the same way, you can actually move that metadata into a managed space or make that metadata available for others. There's probably going to be a process around that because someone from IT is going to want to look at it and make sure that they understand it. But the mechanics are there to move it and to merge it with other stuff that may have been created by IT.
Okay, good. And a couple more detailed questions here. We always have a knowledgeable audience online. One of the attendees writes, So for users to be able to link to the warehouse from their sandbox, they have to understand the right keys and data types of the warehouse to do so. Is that accurate?
Only of the thing that they're linking to. So, you know, if you've got a customer master, for example, you're going to want to link by email address or customer ID or something. So they're going to need to know that, yes. They shouldn't have to know this slide. This is the slide we're protecting them from. The other slide where they're drawing one line from table to table, they would need to know that. They would need to know that this customer column in the table that they just uploaded matches the customer column in some table in the warehouse.
Yeah, that's very interesting. And what's your, I mean, what has been your experience working with people when you've rolled this stuff out? I have to think that once folks wrap their heads around what you're doing, it's a sigh of relief from multiple camps, right?
Yeah, I mean, it relieves IT of the pressure of being responsible for a lot of the infrastructure. It also allows them to publish a menu of different data sets to different organizations. So it removes a bunch of the burden, but allows them to still deliver you know, distributed analytical capabilities out to the organizations, and lets users exercise more self-service capability throughout the organization. So what we found is, you know, you get a greater proliferation of data use. You get more usage of the data that you already have.
Mm-hmm. Yeah, I can see that being the case. And you guys have taken a fairly interesting approach here. I mean, you've got all kinds of competition taking various angles on enabling business analysts or self-service BI, that kind of thing. But you seem to be really, just by virtue of your architecture, honoring the data warehouse construct and the policies around it, dealing with acceptable data governance issues, but also trying to kind of shorten the gap between what a business user needs and what a strictly run data warehouse environment provides, right?
We think they're both valuable, and that's the thing. Is I think, you know, the user community has been given this choice where they feel like they have to choose between, you know, legacy BI systems, which are great around being centrally managed but very heavyweight, and these discovery tools, which are, you know, which make fairly simple problems simpler. But the enterprise data ecosystem is much more complex than that, and we see that both of these serve useful purposes. And how do we bridge the gap? How do we create a single framework where both of these entities can live together and not fight each other? That's kind of the goal here. Is they're both important. They're both important usage models, but they shouldn't be islands in and of themselves.
Right. No, that's a good point. And you'd mentioned this before, but there's a question about it. Underneath where Birst sits can be any number of data warehouse types,
correct,
right? You don't really favor one or the other, but it's a SQL-based system.
It is a SQL-based system. Yeah, part of what we do is you know, we live on top of SQL-based databases.
Okay, cool. Let me see if I missed anything. I saw a few good comments on the tweet stream. Thank you for those, folks. I know there was one other. Okay, so here's one good question. If the user links fields incorrectly, causing duplicates, for example, would that impact or overload the warehouse performance? And is there some kind of a warning the system will kick out?
So we do allow permission levels for how, when a user kicks a query off against the system, you know, there's governance around how long that query is allowed to execute, how much resources. There are ways to set this up so you can control the amount of resources an individual kind of lower privileged user can consume from the system as a whole, so that they're not going to bring the system down. I mean, the thing to keep in mind is what we're trying to do here is create this vision where the data warehouse is an analytical environment. It's not just a staging area for data. So you know, you do need to keep that in mind, that people will be running more queries against that database, and it will get more utilization. But that should be a good thing, not a bad thing, if it's controlled well.
Right, and we got one more really detailed question. Well, and with that, attendee wants to know, you mentioned that you maintain a virtual data warehouse from the model. Do you handle type 2 dimensions and time history of facts as well?
Oh, I love you. Yes, that's a big part of it. I mean, ultimately, for analytics, change is so fundamentally core. So part of what that's a great example for some of the automation that we do is you can select a data source and say this is going to change over time. And under the covers, what we're actually doing is creating a type 2 structure to handle that as is, as was behavior. We also handle snapshotting and a whole bunch of things for time series behavior. And we create a whole bunch of time variants of data, of metrics as well. So when you create one metric, you don't have to create all the different variations of it for all the different time things. We do those types of things as well, assuming that you're going to want to do a lot of time series analysis of data.
That's a great. I'm glad that person asked that question because I'm pretty sure you wanted to make sure to get that across. That's a good. That's a very key component right there. So good deal. Okay, folks, we've burned through an hour and change. It always flies by here in the briefing room. Thank you for these wonderful questions, folks. We always get great questions from the audience, and that helps keep me on my game. I can tell you that much. Helps keep the vendors on their game too. So thank you so much once again, everyone out there in the audience, all those folks out on Twitter. A lot of great tweets today. And with that, we're going to wrap up, folks. So we will archive this webcast. We archive all these webcasts at InsideAnalysis.com. Look under Webcasts, under the briefing room, and recent episodes, and that's where you can always find it. And with that, we will end our event. Speakers, stick around just for a quick post-conference. We'll catch up to you next week, folks. Take care. Bye-bye.